public holiday for Hari Raya, and after that the class will resume as usual. It's just that we are going to conduct everything online.
For students after Hari Raya, they will have like midterm exam.
Oh, okay.
So I don't think they will like study in Hari Raya.
Actually, we just started, so this is the second week of the semester.
Oh,
Just started actually.
in the beginning. Oh, I see.
Okay.
Okay, I'm guys. I don't know if it's reading. First of all, I'm really sorry because I understand like I apologize for your time. I think I was stuck like taking motion. So we like supposed to the time on our needs. Okay. So here, this person will introduce you first to our student. Okay. She is the first one. She is from the University of Australia. Actually, of faculty of
Computer science and IT.
that's thank you. She will help me in our course today with the title of and presentation. So
Very good morning to everyone. Right.
progress.
So it's to see all of you for a topic in the topic machine learning. Processes, right? Actually, the term is for is it? Before I proceed with our topic, so may I know that all of the students are from data science students, is it? Are they data science students? Are you guys data science students? Anyone?
We are data science students.
Oh, okay, all right. So all of you are data science students, right? Okay, so that's why, as you know, that machine learning is very important in data science. In data science, you need to do some kind of analysis, and so on. And one of the technique that to be used is machine learning, right? So that is why it's very important to know about machine learning, right? So let me share my slides, which I've just shared the slides with Dr. Marima. I just shared the slides with you. Right? So okay. So I think just now Dr. Marima has introduced me. So my name is Norisma. All right. Currently, I'm the dean at the Faculty of Computer Science and Information Technology. Here we have a few departments. All right. I'm from AI department. Basically, previously I was the head of department for AI, and then I was the deputy dean. And then this year I'm the dean for this faculty. All right. And in this faculty, we also have programs like AI programs as well as the data science program. All right. It's just that the difference between our data science is that our data science is we have what we call as industry mode, where the students will spend their time longer at the industry compared to the conventional mode. All right. Okay. So today we are going to look at about a topic on data labeling, exploration, and pre-processing. So as you know that this is part of the topic in machine learning, and as you know that like for example like data labeling and these techniques, labeling, pre-processing, they are very important in AI, right? Because as you know that in AI and also data science, there are two things that are very important. One is the data, right? Another one is the model. Okay. So regarding to the data, so there are so many processes that you involving the data. Like and here we are going to look at what are the processes, right? And the second one is the model or the algorithm. All right. So that is why in AI, the models and algorithms are very important. Okay, regardless whether you are doing on the natural language processing, which involve only text, right? Text processing, or involving image, right? Image processing, right? Or speech, okay, sounds, speech, which involve speech processing. So even though the types of the data are different, but still they will have to go through the same process, right? Whereby regardless of the data are images or text, they'll still need to be able, they still need to be pre-processed, right? Before it can be used for it can be used for training, before it can be used to train into the models that we have identified and so on. Okay, so all right. So the topics that I'll be sharing with you today, first, I'll just a brief on the introduction to machine learning first, all right? Because these topics are related to machine learning. So I just want to recap a bit on machine learning. I'm sure that you have learned this, all right? But we just go through briefly, right? Before we go to the our focus today, which is on the data labeling, data exploration or EDA, and also pre-processing. Okay. So as you know that for the machine learning, it has been introduced in 2000s, early 2000 at that time, right? And before that era, everything will be, or AI is only using the rule base, all right? We normally use rule base, and we use experts to acquire their knowledge, right? So that was what I did last time, because I started my doing the research on AI since 1999, 98. At that time, there was no machine learning. All right. So what we did, we have to depends on the experts. All right. So it depends on your domain, whether your experts are coming from the medical, coming from education or linguists and so on. So you will have to rely on the expert in order to acquire their knowledge. Not only data, it's not a data collection, right? Acquiring knowledge from experts are not data collection, right? It's like heuristic rules. You develop the heuristic rules, right? You develop the rules, right? So that is what we call rule based. And that was the early AI, all right? And we normally try to perform simple tasks. But even though we say that it's just a simple task, but at that time you can see the development of AI, such as chess and so on. All right, so you'll be impressed on the system or the AI at that time. All right, even the chatbot. We have our earliest chatbot, Eliza, for example, right? So at that time we feel that this is very, very very good, and it's seems like you are talking to human, right? And then after that, from 2000s, early 2000s, that was the time when they introduced internet. All right. So at that time, you use internet, you use internet as a communications, right? So you communicate using internet. So from there, you can see, we can see that we started to have a bunch of data. All right. So, and then after that, when they during the first, when they introduced the machine learning, normally we use that you use statistical methods as well, okay, to make the inference. And at that time, we normally use machine learning for decision making and also predictions. Okay. Then after that, when they started to see that the data is huge, right? Vast data. That was the time where they have social media. All right. When we started to have social media, the data from time to time escalated so much, right? So from day to day, we can see the increase of the data, right? It's very fast. Okay, so that is why from machine learning, they started to introduce deep learning technique where they use some kind of neural networks, all right? Compared to machine learning, is like supervised and unsupervised, but for deep learning is more on the neural networks, and we need to have huge data as well as the machines. All right, very, very powerful machines like GPU and so on. All right, so that is the time where we can see the process or the era of the era of AI. Okay, so we need to know, we need to understand what is machine learning all about in order to understand why we need to use the data labeling, why we need to have the pre-processing and so on. All right. So as you know that in machine learning, data is very important. All right, because we need to feed the data to machine learning in order to train that data. All right. And in machine learning, as we know that there are two types of models, supervised and unsupervised, right? So of course, for the supervised model, the data to be used must be labeled, right, or annotated, right? Because they need to train the labeled data in order to make sure that they can come up with, the model can be trained by using the data, right? So in this case, these are the examples or the comparison between machine learning and a traditional approach, where previously, when we use rule-based, of course, we still use data, right? But we are not depending too much on data. We are depending on the knowledge that we acquire from the human. So from that, we develop the rules, right? We develop the models, right? So together with the data, right? You will get the answers. But for machine learning, we use data, right? And then we also have so-called like the answers to the prediction labels, right? And from that, we can come up with what is actually the pattern or the rules models for the machine learning. So this is the difference between machine learning and also the rule-based method. So just look at this scenario where can you create a set of rules to accomplish this? For example, to predict and recommend a list of songs to a user from a catalog of 50 million songs. All right, of course, yes, you can, but with 50 million songs, where are you going to complete the whole prediction? All right, if you are using the rule base. Okay, so beat a world champion at playing chess. Of course, because previously we also have last time we do have chess blue what is it called, the name of the blue something, deep blue, where this chess, AI chess, beat the world champion Kasparov, right at that time. Okay, so it means that at that time, yeah, we AI is capable of developing such a good system, right? Determine whether or not the person is obese based on the body mass index, okay, and identify the author of a written article. So if you look at all this scenario, right? Yes, of course, we can develop a set of goals, but sometimes due to the huge amount of data, right? So it's a little bit difficult for us to accomplish all this, right? So that is why machine learning is very important and is needed. And when do we use machine learning? As we know that nowadays data never sleeps. All right. So look at all the all the apps which created data every day. For example, Netflix. We watch Netflix every day. All right. So from that, they can capture your preference, what you like, what you don't like, the movies that you like, and so on. Right. That is why every time you watch movie and every time you on the Netflix again, they will suggest these are the preference. These are, you watch a lot on the horror movie. So the next time they will recommend you new horror movie and so on, right? And also, like for example, like Google. Of course, Google has been used for more than 10 years, right? So from time to time, they keep on trying to improve their engine and so on, the Google translation, the search engine and so on, right? Where previously Google, they only use machine learning and deep learning. And then after that, from time to time, now they use pre-trained models, okay? So they are trying to, they try to improve, and at the same time, when we use Google, we search and so on, they are collecting data from us as well. All right, so that is why every day, all these apps, they generate data, right? So that's why they say data never sleeps. So why do we use machine learning? One of the reason is because maybe of the human expertise does not exist. For example, like navigating on Mars, right? Maybe the tasks cannot be accomplished by human because of the danger of the nature of the task. For example, bomb diffusion. So as we can see in the most of the movies nowadays, when you want they want to defuse a bomb, normally they will send a robot, isn't it? All right. Models are based on huge amounts of data, right? For example, genomics and so on. All models must be customized, like personalized medicine or like Netflix, right? They try to personalize your preference, right? Personalize your interest in terms of watching movies and so on. Okay, even Amazon, they have that personalized where they can track your interest in terms of the books, titles, and so on. Okay. So as you know that the machine learning process, we start with the defined problem statement, and then after that, you need to collect the data. You need to do the pre-processing, right? The data pre-processing, and then you will have to train the models once you have pre-processed the data. So it means that you are ready with the data set and everything. Then you identify the models to be trained, to be used, and so on. So you train the models. And then, but of course, in order to use the model, you will have to decide whether your focus is on the classification or regression and so on, right? And then after that, you evaluate the models to look at the monitor, to look at the performance of the model. And after that, once everything is okay based on the performance and so on, then you can deploy the models, right? Where it can be used with the real application, real scenarios, right? So this is basically, these are the process for machine learning. So as you look at into the process, so from here we can see that how important the data is. All right, starting when you collect the data. All right, so here you can see that without data we can't use machine learning. Right, so and then after you have collected the data, this data cannot be used directly in order to train your models. So you have to go through the pre-processing data and so on. So this is the thing that we are going to focus today, which is on the data labeling, data exploration, data pre-processing, where you will have to prepare the data in order to train the models in machine learning process. Okay. So we will start with the data labeling first, all right? So again, as we look at the name of the title, data labeling, all right? So it means that you need to assign labels or assign tags to the data to make sure that the machines can understand about the nature of the data. All right. So for data labeling, the process may include, for example, like tagging the images. If you are doing it for the machine learning image processing, right? So you may have to tag the images, all right? Or if you are doing it for speech processing, so maybe you will have to transcribe the audio, okay? And when you collect the data, so normally you use like a record. You need to record from the participants and so on. So from that, you will have to transcribe the audio in order to process the data. Or if you are doing on the natural language processing, right? So you will have to highlight about the relevant text and so on. Okay, so in NLP, natural language processing, this is very process data labeling and pre-processing is one of the very important process, and also not only important, and also it takes time. All right, consume a lot of time. All right, sometimes when you look at the process, it's not the training the model is the hardest or the most difficult. Sometimes preparing the data set is the most difficult process, right? So why are we so concerned about the data? Because normally people are only focusing on concern about the models that they use in machine learning and so on. It's actually they have to understand that there are two important things in machine learning or in AI: data and the models, right? So data may also may affect the accuracy of your performance as well, right? So that is why taking care of the data is very important. So label data is very important for training the machine learning models, so that it will enable the AI algorithms to learn, all right? Because once you label, they will learn whether about the label, all right, and make accurate predictions or decisions. For example, if you are doing on sentiment analysis, all right, since I'm from NLP, so I'll give more example on the text, all right. So for example, if you are developing a sentiment analysis, so as you know, for sentiment analysis, it's about the sentiments, right? The polarity of the sentiments, right? So say that you want to have you collect data, right, from the social media, right? And then it's a fresh data from social media where you scrape the data from it, and then it's unlabeled, all right? So when you want to do a sentiment analysis and say that the model to be used would be supervised learning model, right? So of course you will have to annotate the data, right? Where this data should be annotated whether it is positive or negative, right? So say that you use 1 and 0. 1 is for the positive, 0 is for the negative. So you will have to give annotators to annotate the data one by one, right? So once it is annotated, it is labeled, right? Then we can use the data set for training, right? Which means that you want to ask the model to learn which statement will give you positive polarity or positive sentiment, which statements or sentence will give you negative sentiments and so on. So you train the models according to your data set which has been labeled, right? And why it is very important for us to do the data labeling, right? One is because of the in order, as I said just now, it will give effect to the performance of the model, all right? So to enhance the model accuracy, it's good to make sure that our data is well labeled, all right? So that it will ensure that the model learns correct patterns and it will give result in a higher accuracy and also reliability, right? So just imagine, which means that the labeling process must be done correctly, all right? So it can't just be it can't just label according to your you feel that based on just for the sake of labeling, all right? So it has to be done correctly. It has to be done with, for example, if you want to appoint annotators, all right? So you have to make sure that the annotators have the ability or they have the knowledge on how to label the data, all right? If you just give someone that has no idea about the data, so it's going to jeopardize your results, the accuracy of your model later on, right? And if you are using the supervised learning, of course, you will have to do the data labeling, right, for enabling the supervised learning. And according to the Gartner, the report by Gartner indicates that 85% of the supervised learning models are dependent on the quality labeled data for optimal performance, right? So which means that you must make sure that the data is being labeled carefully, right? And of course, we want to reduce the bias in models because if we have a proper data labeling, so it will help in reducing the bias in machine learning models. So this is what we have learned. Are they from the same group last 2 weeks or not? Not the same group. Not the
Not
oh, okay, sorry. All right. Like the last 2 weeks where I shared about the ethics in AI. All right. So one of the thing is about the bias, right? So this is data labeling is one of the way on how we can reduce bias in our AI models. Okay. So, all right. So what is the process for the data labeling? Right? So the first one is data collection. Of course, before you want to do the label, you will have to have the data, the raw data, right? So these data can be you can gather the data from various sources, such as you can use like sensors. If you're doing the image processing, maybe you use all the sensors, all the to capture the images and so on, or maybe the database from the database, any databases, or from the social media, you just do the web scraping, right? Or and also user generated content. Okay, so so these are some of the sources that can be used to collect the data, and then after that you need to do data preparation, right? So before you do the labeling and annotation, you will have to make sure that you prepare the data, check the data, try to remove the irrelevant or duplicate data, all right? Try to handle the missing values and then standardizing the format of the data, right? So before it has to be hand over, or before you want to hand over the data to the annotators for the labeling or tagging, all right? And then after that, of course, you will have to identify who are going to do the labeling or annotation. So for annotation, there are two techniques, strategies to do the annotation. Of course, most of us are still relying on the manual annotations, which means that we use human to annotate the data set and so on. And in order to do the manual annotations, you will have to come up with some kind of a guideline so that it can be followed by the annotators. All right. So normally, we have 2 layers of annotations. All right, whereby the first layer is on the annotators. The second layer will be those expert to verify or to validate the annotations. All right. So this is to prevent from being, for example, like being biased and so on. Okay, to make sure that what we annotated, what is being annotated is correct, or the quality is optimum. All right, and then this is where we have a quality control, right? We validate the label data to make sure that it's accurate and also consistent. So for the quality control, it may involve some cross-validation techniques, all right, where like just now I said, the 2 layers of annotators, where we have different annotators review the label data and disagreements are resolved through consensus. So if there are disagreement, then they will have to discuss about which label or to be, or tag to be used and so on. All right. So normally for NLP project, annotations process is very tedious, right? Where you will have to follow the guideline, all right? And then there must be a quality control in order to make sure that the annotations are correct. But at the same time, we can also have a semi-automated annotation, all right? Where first we do some kind of manual, we fit some data for the manually, and then after that, by using the sample, we can train and we can automate the annotations process. Okay, but so far we are still depending on the manual annotation. Okay, so there are many types of data. As we know that it depends on the nature of our project, whether it's going to be images, text, or sometimes numerical data, all right? Like for example, if you are dealing with banks and so on, so maybe most of the time, the data will be in numerical data, all right? Or even we can also have sequential or time series data, all right? So for numerical data, normally they are stored as a CSV format, right? And images normally are from the abundance of pictures about objects or scenes, all right? Even nowadays, we also have videos, all right? Data related to videos. Because for images, it's just a static image, all right? But we also have videos where they can capture some images and so on, right? And for the text normally related to natural language processing. So we know that for text is unstructured data, right? So we from the unstructured data, you will have to go through the process, the pre-processing and so on, in order to make it more structured before we can use that for to train the models and so on, right? And the last one would be the sequential or the time series data, or even nowadays we also have the live data, right? So all these the types of data, they have different types of challenges, right? And different types of this data may have to we have to make sure that we are clear of what types of data that we use in our data sets, right? So for the annotation, there are various annotation tools and techniques are employed, and it depends on the types of data that you use. Okay, so we have image annotation, where we have tools are used to draw the bounding boxes, the polygons, or the landmarks about objects within the images. And then we also have text annotation. For text annotation, sometimes it's more like we identified the keywords or the sentiments, or even the like part of speech, right? So we tag the part of speech of each word and so on, the class of words of the words, all right? And then we also have audio annotation, where we use sound segments, where it has to be transcribed and then annotated with the timestamps and also the labels. Okay. Okay. Now we go to the data exploration or exploratory data analysis, or EDA. All right. So in data analytics or data science, data exploration is very important. It's a critical initial step in the data analysis process, where from the raw data, it is examined in order for us to understand the underlying structure of the data. All right. So why is it so important? First, because we want to gain understanding with the data sets, features, and also the limitations of the data. So you want to study about the data. All right. So what are the features? What are the limitations, and so on. Secondly, why we do data exploration? Because we want to identify the data quality issues, such as the missing values, the inconsistency, and so on. All right. And also, the third one is actually to develop the initial insights and hypothesis. Right? When we do the data exploration, although it is not the actual insights, but from here, when we do a data exploration, we actually has generated the initial insights and also the hypothesis from the data itself. All right. Okay, so how to perform the EDA? So from here, there are several processes for to perform the EDA, right? So again, it's like data labeling just now. First thing is we need to get the data, all right? So we have to collect the data, where this data can be from different sources as well, right? From the websites, from the APIs, databases, and so on, right? Okay. So once you have collected the data, right? In terms of the when you want to do the processing, right? So as we know that when you use all these tools on Python, right? They already have divided all the libraries that can facilitate the data manipulation, visualization, and also analysis. Right? So maybe we'll have to think of what are the functions, what are the things that to be done with the data. Right? So from that you will identify what are the libraries to be imported. Right? Because we need to import the library in order to do the analysis after this. So perhaps you want to use pandas, right? Where it is used to read, manipulate, and also to analyze the structured data. Okay? Or maybe because it's related to numerical, mathematical functions and numerical, so you want to use NumPy. So you import the libraries and NumPy libraries, right? Or perhaps you want to create the visualizations, right? You want to plot the histogram and so on. So you will have to import the matplotlib pyplot, right? So this is related to data visualization. So it depends on what are the functions to be used. So you will have to identify the libraries and you will have to import the libraries. Okay, right. Then after that, we look back into our data, right? Where we have collected the data. Now we need to do some kind of cleaning, right? Data cleaning, right? Before we want to use or we want to do the exploration, we have to look into the data. What are the issues with the data? All right, is the data ready to be used or not? All right, so try to identify and then resolve the data quality issues. For example, like missing values, all right, outliers, duplicates, which can affect the accuracy of the analysis later on. All right, so once you have collected the data, you will have to screen through the data, look at the data. Is there any missing values or not? Is there any outliers or duplicates and so on, right? So if yes, then you will have to address all this kind of issues. All right. This is examples of how you want to import the libraries. All right, import pandas, import NumPy, and so on. Okay. All right. So for data cleaning just now, so there are a few issues that can be addressed during data cleaning. All right. The first one is about to address the outliers. All right. You know what is the outliers, right? Anyone knows what is outliers? Can someone explain what is outliers?
Can I answer?
Yeah, please.
So outlier is a data that has kind of different characteristic with another group of data. I mean, with the most of data.
Okay. So why
yeah.
do we want to address the outliers?
So because outliers sometimes can disturb the variation or the distribution of data. So it can broke the model, so it failed to understand the data. I mean, by cleaning or just removing the outlier, model will be helped to understand the data easier.
Your name again just now?
Pardon?
Talking to Elzandi Irfan, is it?
Yes, my name is
Irfan.
Alexander Francisco.
Irfan, okay, Irfan. Okay, thank you, Irfan. Right, okay, yes, right. So, as what Irfan mentioned just now, okay, So is 1 second. So here I'm so sorry that there is some kind of noise back. They were doing some grass cutting, all right? So there was some noise back there, okay? But I hope you can hear my voice, right? Okay. So again, as what Irfan mentioned just now, the danger about the outliers is that they can give different interpretations, all right, because of these outliers. So that is why it's very important for us to address the outliers. And some of the strategies to handle the outliers is either you remove the outliers, all right? So you totally remove the outliers, right? Or you transform the outliers into a normal or others like the other data set, right? So you will have to consider whether you want to remove or transform. Of course, if you have a lot of data, all right, your data is huge. So of course, you can just remove the outliers, right? But if say that your data is not that much, all right, and of course, if you want to use data machine learning or especially deep learning models, of course, you need to have a lot of data, all right? So if you keep on removing all the outliers, you remove all the missing values, duplicates, and so on. So perhaps your data might be reduced to about 20 to 30%, all right, which will give impact to the number of the data set that you have, all right? So I think from that, that is why there is another alternative where you can also transform the outliers, all right? The second one is about identify and deal with missing values just now, right? Missing values is also another big issue, right? In handling the data, because for missing values, it will give effect to the accuracy of the models, all right? If you don't do anything about it, all right? So it will affect the accuracy of the model, all right? So that is why for the missing values, you could either delete the missing values, right? Whereby you remove the rows and columns of those affected or those who have missing values, or you can also do imputation, all right? To impute the missing values with reasonable data. Of course, you will have to analyze the data in order to impute the missing values, all right? Because we can't just simply put any values, all right? Just in order to cover up the missing values, all right? So it has to be reasonable data. So there are two ways of how to handle the missing values. And again, it has to be depends on your the amount of data. All right. As I said just now, if we keep on delete all the missing values, you will have to delete to remove all the rows, the columns, and so on. So which means that say that if you have initially you have collected 1,000 data set, excuse me, sorry. Sorry. So so maybe after you have done the deletion and so on, so maybe it's just about 70 to 80% left for the data set, right? So that is why you will have to decide whether you really need to delete the missing values, or you need to rectify it or do some kind of imputation. All right. Then you also have to identify and remove duplicates from the data set. In this case, there is no other way, it's just to remove the duplicates, all right? Because of course, we don't want to have the same data, all right? And it is calculated twice, all right? Because it won't give effect to the model. And remove or correct irrelevant data. All right. So in order to do that, you will have first to identify the irrelevant data. Say that you collected about data about sentiment analysis. All right. And suddenly the data is not about the sentiments, it's more on the talking about the facts, factual and so on. So it means that the data that you have collected is not relevant to what you are doing, all right? Because you want to do a sentiment analysis, you want to develop a sentiment analysis. So the data should be about sentiments, all right? So in this case, you will have to evaluate the data quality just to make sure that it is not relevant. And then after that, you remove the irrelevant data. All right. And in data cleaning as well, you will have to detect and deal with invalid or inconsistent data. All right. So sometimes when you look at in the data, right, you will spot some invalid or inconsistent data. All right, the data is not consistent. All right, perhaps about the amount. Maybe in the data you were talking about the salary of teachers. All right, so the salaries of teachers normally range from 5,000 to 12,000. All right, so suddenly there was some data with the salary up to 30,000 or 50,000, which is actually not consistent or invalid. All right, so from here, for the invalid or inconsistency of the data, so it's either you can remove the data, all right, because if you look at the data, it's not valid at all, so you can just remove the data, or you can also do the imputation, all right, where to find the most valid data, all right, by looking into the pattern of other data and so on. And it can be done by manual corrections, all right, or data transformation, all right. So that would be for data cleaning. So for data cleaning, one of the most critical is about the missing values. All right. So let's look at in this table the example of the missing values, because missing values or missing data in the training data set, it can lead into the bias model, right? Because we have not analyzed the behavior and also the relationship with other variables correctly. So this can lead to the wrong prediction or classification, all right? For example, let's look at the table. Table on your left is those table with the missing values, and table on your right is the table that which has been deal with missing values. All right, so in this case we do not remove the missing values, but we do the imputation. All right, so let's look at the missing values, the table on the left. Right, we have two missing values. Say that you want to predict about about gender, whether male or female has the higher percentage of play cricket, right? So here, if you look at the table, all right, so it looks like male has higher percentage of playing cricket, right? So we have 4 students. 2 of them play cricket, so 50%, right? But there are 2 of them. Whereas for female, there are only 1 who played cricket, all right? So male is greater than the female, right? But if you look at the table on the right, after you have addressed the um, issues on the missing values, right? It looks like female has higher percentage for playing cricket than male, all right? So based on this example, right, if it shows that if you don't deal with the missing values, it can lead to the wrong prediction or classification, right? So that is why it is very critical for us to know about this missing values, to deal with all the missing values, okay? And there are reasons for missing values, right? The first one is errors at data extraction, okay? So this is during the data extraction stage, where it's like human error when you want to extract data, right? And suddenly, perhaps due to some reasons, you extract the data wrongly, or maybe you miss to extract specific columns, rows, and so on, right? So that is why during the data extraction stage, right, these errors may occur and it will result into the missing values on your data, right? And there are also quite a number of cases where errors occur at time of data collection, right? So for data collection, it may be due to so many reasons. For example, if you are doing a data collection with correspondence, right? You ask the participants to fill up the blanks and so on. And sometimes the participants, they are not willing to, or they are not sure of what to write and so on. So they leave it blank to some of the field, right? And that, so you will be getting some missing values for some of the fields and so on, right? So this also is a major issues during the data collection, where it will result into missing values. And in order to address this, you will have to find, or you will have to look at into the patterns of the other data and so on, right? Okay. Then from there, you will do the data exploration, right? Where for data exploration is more on to helps to identify the patterns and also the trends, and form the basis of the data analysis phase. A number of EDA techniques, which include, like, for example, the summary statistics, all right? Or sometimes you do visualizations, right? So in data science, I'm sure that you learn about data visualizations, right? And also correlation matrices. So these are some of the techniques that can be used for data exploration. And of course, after that, you need to do the data analysis. After you have done the data exploration, you do the data analysis, where use the various techniques to gain the insights into the underlying structure and the relationships in the data. So the common techniques that use normally clustering, regression, and also classification. Okay. Dr. Mark, can we take two?
Yes, sure.
All right, thank you.
So, guys, we take a break, 2 minutes.